Hello and welcome to this video. In this video we will talk about the solutions to the first assignment in our course Competition Policy and Strategy. This assignment is on the topic of perfect competition and monopoly, and in particular this video will cover the solutions to the first exercise on this first assignment. The first exercise is on perfect competition itself. The task reads: consider a market with perfect competition where n firms offer a homogeneous good. All firms have identical costs, characterized by the following cost function. And the cost function is given as written on this slide. Capital C of Q equals Q squared plus 25. This cost function is defined for any positive quantity Q, and in addition we assume that the total cost, capital C, of a quantity of 0 equals 0 too. Then further we know that the demand function is defined as written down here. So the demand function D as a function of the price P equals 240 minus 10p, where P denotes price and Q denotes quantity. Now, in the first part of this exercise, we are asked to find the short-term market equilibrium for the case of n equal 20 firms in the market. We are then asked to calculate profits of each firm, calculate consumer surplus, and then finally calculate the total welfare in the market. So let's start by laying some groundworks. First, we have assumed in this exercise that we are talking about a market with perfect competition. That means in this market the following condition holds, namely P equals MC, so price equals marginal costs in equilibrium. How do we know this? Where does this come from? Well, if we simply have a look at the profit maximization problem of each firm in this market, which is written down here, right? So each firm maximizes its profit pi as a function of the quantity Q, which equals the revenue minus the costs of the firm by choosing the profit maximizing quantity, right? Now, the revenue function is quite easy to find. We simply can calculate revenue as the product of price and quantity. The cost function at the same time is given in the task. So capital C of Q was given in the exercise. But we do not even need to know how C is defined precisely in order to find out that the price in equilibrium must equal the marginal costs. Instead, we can just stick for a moment with this very general case. And in order to find the profit maximizing quantity, we will of course have to have a look at the first order condition of said maximum. So what we should really write down here is this is the first order condition. And in this first order condition, so the partial derivative of this profit function with respect to the quantity the firm will sell on the market equals this expression, namely P minus marginal costs, which itself is a function of the quantity. And the first order condition of this maximum, well, then implies that this expression has to equal 0. If we simply rearrange this expression, we will, I hope quite obviously, result with the expression which we wrote down right at the top of the slide. All right? So that's the first crucial part of the solution of this exercise, that we understand that in perfect competition, in equilibrium, the price must equal marginal costs. In addition, we also know that we are looking at the market in the short term. Short term implies that there is no market entries and no market exits. No more, no less. And then finally, in order to find the equilibrium, we of course have to find the situation where the supply equals the demand, right? So yeah, the supplied quantity needs to equal the demanded quantity in the market. Now, how do we proceed from here? We have figured that we need a quantity function, or a supply quantity function and a demanded quantity function. Let me first go ahead and erase all of this. The demand function, of course, is already given in the exercise. So what we need in order to find the equilibrium is the supply function. How do we find the supply function, the market supply function, Q with a subscript S of P? Well, we find this supply function by horizontally aggregating the individual supply curves. So we have, by assumption, 20 firms in the market. Each of these firms faces their own costs of production and therefore has its own individual supply function. And if we want to figure out the total supply function of this market, we will need to aggregate over all of these individual supply curves. Now, how do we determine the individual supply? Well, as we discussed earlier, we know that the price must equal the marginal costs in this market in equilibrium. Marginal cost, of course, is nothing but the derivative of the cost function with respect to the quantity, right? Because the cost function was a function of quantity, we have to derive it with respect to the quantity. And for this particular case, just as a quick reminder, this is the cost function we are talking about, so q squared plus 25, and now the derivative with respect to q, of course, is 2 times q, right? With this, we know that in equilibrium, it must be true that P equals 2 times q. Price equals marginal costs. So with this, we know that in equilibrium, the individually supplied quantity in the market must be Qi equal to Pi over 2, right? Simply by rearranging the equality that we figured out a second ago. Now, what do we actually need to do when we want to figure out the supply function of the whole market? We said that we need to horizontally aggregate all the individual supply functions. Well, and what that means is we simply sum the supplied quantities at any given price P. The supplied quantities of each individual firm summed over the number of firms. So this all comes down in the end to this expression down here. So the quantity supplied in the whole market is the sum of the individually supplied quantities. The sum over, in this case, 20 firms. If we do so, we simply multiply the individually supplied quantity Qi with 20, because now we have 20 firms in this situation, we result at the market supply function 10 times P. All right, that's our supply function. In the next step, we want to find the market equilibrium. And in order to find the market equilibrium, we simply have to find the intersection of the supply function and the demand function, right? Now, we identified the supply function just on the previous slide. The demand function was even given in the text of the assignment, right? So we can simply set them equal, solve for P or Q, you can choose, and find out that the price in equilibrium must be 12. And with an equilibrium price of 12, we of course know by putting this into either the demand or the supply function, we know that the equilibrium quantity in the market will be 120. This of course is the total quantity in the market. And in order to find out what the individually produced quantity of each individual firm is, you of course have to consider that there is, per assumption, 20 firms in the market. So each individual firm gets to sell produce and sell a quantity of 120 divided by 20, so 6. So Qi in equilibrium equals 6. Now, what are the profits in this situation? Well, the profits of the individual firm, of course, is nothing but the difference between the revenues of the individual firms and the cost the individual firm incurs by producing this amount. So if we simply plug in the quantity of the individual firm that we just calculated into our revenue function and into our cost function, we can find out that the profit of the individual firm equals 11. And again, knowing that there is a total number of n equal 20 firms in this market, we can then calculate that the total profits in this market are 220. In the next step, we are asked, so after calculating profits, right, we are now asked to calculate the consumer surplus. How do we find the consumer surplus? Well, technically speaking, consumer surplus is defined as the area below the demand curve and above the market price. So if we were just to illustrate this situation, right, we have this demand function which is negatively sloped, we have some kind of market price, then consumer surplus would be this area below the demand function and above the market price, just as a quick reminder. How do we calculate this? Well, we can integrate the area below the demand function, which is this half, and then subtract whatever is below the market price, right? That is what is written here in two simple steps. In this particular case, where, as I indicated it in the sketch, we have a linear demand function, right? We don't really need to bother with integrals. We can simply calculate this triangular area as what it is, as a triangle, right? So we can simply calculate the consumer surplus given the price and the quantity in the market by calculating the area of the triangle, which I sketched in blue, and we come to the result that the consumer surplus in this market must equal 720. Now in the final step, after calculating profits, consumer surplus, we are now talking about total welfare. Total welfare is defined as the sum of consumer surplus and profits. Well, we already calculated both of them. We calculated profits 2 slides earlier, calculated consumer surplus just now. So we simply calculate the sum of both of these and we can find out that the total welfare in this market is 940. And with that, we are already done with task A and can now move forward towards task B. In this, we are asked to calculate the price and quantity of the long-term equilibrium, how many firms will be in the market, and calculate the total welfare in this situation. All right, so crucial difference between the situation we were just talking about and the one we are going to talk about next is that we are no longer assuming some number n of firms in the market, but instead we are now entering the world of the long-term equilibrium. So, as I said earlier, in this long-term equilibrium, the number of firms really is not just assumed, but instead results from free entry and free exit. We are also given one additional hint, so the solution of this exercise is that much easier. And the hint reads, the marginal cost function, so MC of Q, intersects the average cost function, which we will call AC of Q for average costs, in the long-term market equilibrium, right? Just a hint that we can use if we want to in order to solve, for us to solve this question. Now, let's start again by some easy interpretations. First, again, the long term means that market entry and market exit is now allowed. And then, similar to what we saw earlier, the equilibrium again denotes the situation where the total quantity supplied equals the total quantity demanded, right? Also, in this particular case, because we are still in the world of a perfect competition, right? We also know that in equilibrium, economic profits must be zero. Or, in particular, price must equal marginal costs, and also price must equal the average costs. All right. So, what we know from the fact that there is zero profits is that all firms must produce in the average costs minimum. We know this first from the fact that market entry is allowed and firms will enter and exit until the production actually happens at the average costs minimum. We also know this simply by reading the hint carefully, right? So one way to solve this question is by simply finding the minimum of the average costs. And the average costs is, of course, calculated by dividing the total cost function, capital C, by Q. And if we do so, we find out that the average cost as a function of the quantity Q equals Q plus 25 divided by Q. In order to find the minimum of this average cost function, we can now calculate the first order, we now first start by stating the first order condition of this minimum. So we initially have to calculate the first order derivative. And the first order derivative of this average cost function equals 1 minus 25 divided by Q squared. And of course, in order for the first order condition of this minimum to hold, this expression needs to be equal to 0. Well, there is only one truly feasible solution to this expression, namely the quantity must be equal to 5 in order for this minimum to be reached. Now, of course, we also glossed over this in the previous problem. Of course, we actually have to check the second order condition for this to be an actual minimum as well. For this exercise, we can skip this part in order to keep this nice, clean and simple. We can simply argue that by strict concavity of this average cost function, as we can see it written on this slide, we know that this must be a minimum, right? And we will, for the remainder of this class, typically just make sure that the properties of the functions that we are looking at ensure that we are actually finding maxima or minima respectively. So we don't have to bother with the second order conditions. All right. Now, what is the price and the quantity in the market equilibrium, in the long-term market equilibrium then? Well, we have already found out that the equilibrium quantity of each individual firm is 5. Now, in order to find out what the price is in this market equilibrium, we can again make use of this condition that we stated earlier, namely that the price must equal the marginal costs of each individual firm. The marginal cost, of course, we already calculated it, is 2 times Qi. If Qi equals to 5, which we just identified, then of course we know that the price must equal 2 times 5, so 10, right? So now we know the price in market equilibrium, and if we know the price in market equilibrium, then we can of course calculate the total quantity that is sold or demanded in this equilibrium, which of course is the same. It must be the same in equilibrium. So at a price of 10, the total quantity demanded and the total quantity supplied, of course, is equal to 140. All right, now we know the total quantity in the market. We also know the quantity that is produced by each individual firm. So knowing these two numbers, it's quite easy to calculate in the next step how many firms there will be in the market in the end. And we arrive at the result of this question simply by dividing the total quantity in the market by the number, the quantity produced by the individual firm. So what is written here is 140 divided by 5, which equals 28. So now we know that there's 28 firms in the market in the long run in equilibrium. All right, now finally we are asked to calculate the total welfare in this scenario. Usually, as we just talked about total welfare, in order to find total welfare, we first have to calculate profits and then we have to calculate consumer surplus as well. In this particular case, we can take a little shortcut because we already know that the economic profits, so pi, must be equal to 0, simply because we know that the price is equal to the average costs. Again, this is the very condition of the long-run market equilibrium in perfect competition, right? So this is, in this very specific case, generally true. Profits will be 0 in this condition, under these conditions. So in order to find the welfare, we can simply calculate consumer surplus. Again, because the demand function is linear in our case, we can simply calculate it as the triangle below the demand function and above the market price. And doing this, we find out that the consumer surplus equals 980, which of course, because profits are 0 in this scenario, also equals the total welfare in the market equilibrium. Now in the next step, we are asked to illustrate the short-term equilibrium from task A in a price-quantity diagram and mark consumer as well as producer surplus. So if we were to draw a graph, it would look like this. So we have the inverse demand function as this downward sloping blue line, and we have the positively sloped inverse supply function, right? And yeah, we also know from our calculations earlier that the market equilibrium price in this situation will be, let me just check again, will be 12 and the total quantity will be 120. So skipping ahead to our beautiful graphs, we can also mark the market equilibrium at a price of 12, and we can see that this, of course, comes with a quantity of 120. So this is the short-run equilibrium. Now, where do we find consumer surplus and producer surplus? Well, we already talked plenty about the consumer surplus, which is the area below the demand curve and the market price, and analogously, the producer surplus is the area above the supply function and below the market price. All right, so these two areas, these two triangles show our consumer surplus and producer surplus respectively. Now we are asked to compare the short-run equilibrium with the long-run equilibrium in this scenario. So how does the short-term supply function differ from the long-term supply function? Well, we already saw that in the long run, more firms will enter the market, which of course results in an individually lower production quantity, right? So overall, what we can see is that the inverse supply function in the long run is slightly less steep, right? So the upper line, the upper orange line, denotes the short run supply function, and the lower one shows the long run supply function. And of course, the new market equilibrium, or the market equilibrium in the long run rather, is at the intersection of this long run supply function and the demand function. And what we can see is that the price now, in comparison to the old equilibrium, of course, is lower and the quantity is larger, right? Which is exactly what we saw in our calculations. Accordingly, the consumer surplus, so the upper triangle, is getting larger in its area, and, well, the producer surplus, it's not, is obviously getting smaller when we move from the short run to the long run. All right, now we are asked to explain why the total welfare is higher in the long term than it was or is in the short term. So what we are asked to explain is what we realized earlier, namely that the welfare under 20 firms in the market is equal to 940, and the total welfare under 28 firms in the market, which again was the result of allowing market entry and moving towards the long run, is larger, namely 980. And the explanation is as follows. In the long run, market entry happens or is allowed, so as long as there is positive profits, or as long as the production is not in the minimum of the average cost function, firms will enter, and thereby the price will decrease. We know, simply by looking back and at our calculations in task B, that the welfare maximizing output is reached at a price equal to the intersection of marginal costs and average costs, so in the minimum of the average costs. All right, that's exactly what we have, like, as a reminder written on this slide. So the marginal cost intersects the average costs function in its minimum. So the optimal market result is in the minimum of the average cost function. As a result, we have in the long run 0 profits, pi equals 0, but at the same time the consumer surplus is maximized. And what we see, for example, in this exercise, is that this will overall maximize the welfare in the market, right? Producers are losing in profits, but at the same time, consumer surplus is overproportionally increasing. All right. Now finally to a more verbal exercise where we are asked to argue the different assumptions that we typically imply when we simply say there is perfect competition without further going into the details. So, name the assumptions that are implied by perfect competition, explain what differences in market outcomes you would expect if these assumptions do not hold. Do you think that a model of perfect competition is appropriate to describe a variety of actual markets, and give reasons for your answers? Quite a lot, but let's just move through it step by step. First, by naming these assumptions and explaining, in doing so, explaining how these assumptions, or how loosening these assumptions would change the market outcome. Let's start with homogeneous goods. So usually in perfect competition, we assume homogeneous goods, which means that the consumer cannot differentiate between the goods, right? It simply does not matter from what firm the good is bought. Homogeneous goods. Typically, if we wanted to give up on this assumption, there is 2 ways to think about non-homogeneous goods, and that is first by vertical differentiation something that we usually associate with differences in quality, like measurable differences in quality. And then the second way of abstracting from this assumption would be horizontal product differentiation, which is usually understood as a differentiation according to taste. In general, what we can see in different economic models and what we will see throughout the semester and the upcoming assignments is that larger differences between goods result in higher price margins. Of course, ceteris paribus, it always depends on the exact and precise model specifications, but in general, this is true, as we will see in the coming weeks. All right. Now, second, the atomistic market structure. Atomistic market structure, well, what does it mean? It means that we assume that each individual firm is atomistically small. So it's too small to have any meaningful impact on the market outcome. It might choose to produce less or more, but that does not influence the total quantity in the market, simply because the individual firm is so small. So what this means is basically each individual firm has zero market power. If we wanted to abstract from this assumption, we could, for example, allow for a few firms. And when we look at a few firms, we typically talk about oligopolies. In an oligopoly, so there's only a few, maybe a handful of firms, we usually account for strategic interactions. So if there's only a few firms, these firms can usually or generally respond to the actions of one another. And we will, of course, discuss this in greater detail in the following weeks, in the upcoming weeks. But for example, if there's only a few firms, these firms might collude and agree on prices or quantities, and then if we now consider strategic behavior, each individual firm can now sit back and think whether or not it might be profit maximizing to deviate from these agreements and instead set a slightly lower price and attract more consumers, right? But these kinds of strategic interactions between firms usually, or in general, are only considered in oligopolistic market structures. And then if we go along this path even further, so there's fewer and fewer firms until there's only one single firm, well, then of course we are in a monopoly, so zero competition or maximum, in general, maximum market power. We should, or we will in general see the largest margins as well. All right, of course, you can always find exceptions to these facts, but right now we are just talking in very general terms. Now, the third assumption is firms are price takers. This is very closely related to what I just said about atomistic market structure. So in perfect competition, we assume that each individual firm has no impact on the price it sees on the market. It cannot influence it. So it is a price taker. It needs to take the price it observes on the market into consideration and cannot influence it, right? If we were to abstract from this assumption, well, then we would be in a model, in a world where firms would consider price and quantity effects in their profit maximization. So if I can influence the price, then of course I can try to push the price into a direction that is maximizing my own profits. Again, if firms are not price takers anymore, this makes it so much easier to consider strategic interactions, because only then, only if firms are not price takers but instead can influence the price on the market, well, only then firms are actually able to set, for example, a price that is slightly larger than their competitor's price and thereby attract a larger group of the consumers and sell more of their items. But again, more on this in a few weeks. Now, the next assumption is complete information, and this usually is, again, quite the broad topic if we were to go into the details, but in general, again, what we see is if we abstract from complete information, so we consider, for example, cases with asymmetric information, for example, regarding the demand function, or for example, regarding the production costs of each individual firms. This again allows for first uncertainty, which might result to some kind of probabilistic decision making. And of course, this also allows for information exchange between firms as another way of interaction. And what this implies, of course, is another way of strategic interactions. Now, the fourth assumption that is implied by perfect competition is that there is no barriers to enter the market. This, of course, is quite closely related to what we were just discussing within this exercise, right? We were talking about a short run at first, simply because a short run is a very handy way to assume that market entry and exit is not possible, right? It's not that fast to enter a market. Now, what we discussed when we were looking at the long run was precisely the case where there were no barriers to enter the market. So firms could just enter as long as they wanted to, which means as long as there was positive profits, they would enter, right? Well, we do not need to be that generous. It's actually quite easy or maybe quite interesting even to consider cases where barriers to entry actually exists, so that firms have to overcome some kind of, for example, investment in order to enter the market and actually sell to the consumer. Of course, these barriers to entry are often regarded as one possible cause of monopolies. So if there is quite substantial barriers to entry, then this might result in monopolies. And barriers to entry can result in situations where the incumbent firms, or the incumbent firm singular, so the firm or firms that are already active in the market, might be able to set higher prices than they would otherwise, simply because it's not that easy for an entrant firm to enter the market and participate from the positive profits that the firms that are already in the market are gaining. All right. Now we are to discuss whether or not these assumptions are anywhere close to reality. So we are asked, do you think that a model of perfect competition is appropriate to describe a variety of actual markets? And we are asked to give reasons for our answer. Well, we could start that in reality markets with perfect competition are rarely found. Just think about any market that you can come up with. Well, it should be quite hard to actually think of a market that ticks all of the boxes that we were just discussing, that actually meets all these strict assumptions that we were just analyzing. So conditions are in part met in organized markets such as commodity or stock exchanges, but even then you could argue that not all of the assumptions are actually fully met. This model rather describes an optimal state, like a benchmark. It describes the Pareto optimum, the welfare maximum as we saw it earlier, right? Against which other markets or situations can be compared. So the perfect competition provides us the Pareto optimal world with which we can then compare other situations. For example, a situation where there is an oligopoly or even a monopolist. The results of this model, so the results of the perfect competition models, are usually considered as a reference at which prices, quantities, profits, etc. of other market forms are compared. Again, going back to this statement, Usually and throughout this course, we will regard perfect competition as a benchmark situation with which we will compare other forms of competition.